everyone, welcome to my YouTube channel. Today in this video I'm going to show the crash analysis in Ansys Explicit Dynamics of crash box. So before getting into the analysis part, first let me explain what is crash box and why it is located. So a crash box is the structure in automobile which is used to absorb the impact energy through controlled plastic deformation, right? And it is located between the bumper beam and the vehicle frame. As you can see in this picture, it has been highlighted, right? Now this crash box is made of thin walled aluminum metal or steel metal, or sometimes it is made of composite material, right? And to understand it better, you can go through some papers or some articles in the internet. So I'm not going to give that much of time in this theory, but we'll see a detailed analysis of it right from the preparing geometry and the complete simulation in Ansys Explicit Dynamics. Okay, so here is the Ansys workbench, and I'm going to do this analysis or going to perform this analysis in explicit dynamic module. So let's get the explicit dynamic, right? First we'll prepare the geometry. So let's open space claim, Ansys space claim, and while I'll be making geometry there itself, I'm going to give you the dimensions, so you can replicate the dimension from there also itself, right? And I'm not going to take the dimensions randomly, okay? So these dimensions are very much realistic or relevant, right? So let's start this. Okay, I'm going to make the square, taking 80 millimeter of these sides, this one also 80 millimeter. Okay, now I'll give the thickness of 2 mm, so the inner sides of the square will become 78 millimeter. Each side is 78 millimeter. Okay, now I'll pull it on both sides, this both side. I'll pull it up to, I'll give the length of extrude 200 mm, so 100 each side, right? Now I will take the rigid element. Okay, so let's take a sketch mode. Let's go into the sketch mode again. Okay. Sorry, I'll again take the define rectangle from the center command. Okay, I'll just give it 100 by 100. So here we are. I'll give only 0.5 mm gap of the impactor. This is also called this impactor. So this will impact the crash box. Okay, so I'll just hide this one. Okay, let's delete this one and let's make complete surface. I'm going to delete it. Okay, I've deleted this one. Okay, let's see. So on. Okay, I'll give a thickness 2 mm. No, first I'm going to move it to 0.5 mm. In this side 0.5 mm, right? Now I'll pull it 2 mm. Okay. Now I'll give the wall, to provide the fixed support to the other side of this crash box. So just let me this distance is okay 202.5. You can also measure this one here. I'll take this one and go to the measure and this measure. So it is 202.5, right? So I'll move it to 202.5. Go to design, then move. I'm pressing control since I'm going to make a copy of it and moving. Okay, so I have pressed control as well. It could be 202.5, right? I hope everything is fine. So I have prepared the crash box. Now let's go to the workbench. First, I'll take the material. So I'm going to take the nonlinear material of aluminum. So in the data sources, here you can see general nonlinear material, then add aluminum alloy nonlinear, right? Okay, let's go to the projects. Here we are. So we have set up the material. Now let's go into the Ansys mechanical window. So I'll double click on the model, then it will take us to the mechanical window. Let's wait for a few seconds to open this. So it has opened. Now we are in the mechanical window. So let's set up the properties. So which one has a gap? Let's see, check it out. Okay. So as you can see, this one has a gap, so we'll make this one rigid. And this one material we're going to give aluminum alloy nonlinear. Okay. This one we're going to make rigid. So let's make it rigid. Now this solid. Okay. Now this one. For this one, for the wall, we're going to provide the structure. We're going to keep structural steel material. Everything is fine. Now for the contact, we'll see for the contact. This will delete this contact, or you can suppress. We'll keep this contact active, right? And we have another contact. This one will act as a frictional contact between impactor and a crash box body tracer. Let's generate the mesh. Okay, so we're not going to refine this on this wall or on the impactor. So we're going to take the coarse mesh for this one, but we'll refine this particular crash box sizing. We'll give here 3 mm. Let's generate the mesh again. So this is the mesh for us. Okay. Now first I'll give the velocity. Here also you can give the velocity. Here also you can give the velocity. So let's keep the velocity. Here is the velocity. We'll take this part, and velocity direction will be a positive y directions, right? So in positive y directions, we're going to give 10 meter per second. So it would be 10,000 millimeter per second, meter to millimeter. And for analysis settings, we're going to give the time of 0.00 0.001, yeah, or simulation end time will be 0.001. Velocity has already been defined. Now I think everything is fine, we are good to go. Let's cross check if any boundary conditions or anything has not been defined or given. Okay, I think everything is fine. Okay, no, we have to fix this one. We need to fix support to the wall, and this will be the impactor. We're not going to give any boundary condition to the impactor. We have only given the velocity. Now we are good to go. Let's solve this. So we have to wait for a few minutes to solve it. Okay, as you can see, 44% of analysis is completed. And also we can see here like how much time remained. So it will take another 40.4 minutes. Another thing we can do, we can update, like we can see the deformations live here. So if I update results, then we can see, yeah, here it is. So this is another feature of Ansys Explicit Dynamics, that during the ongoing simulations you can see the deformation plot, right? So let's complete the simulation. We have to wait another 40 minutes to complete it. So as you can see now, the simulation is completed, and we can see the results now. Let's go with the total deformation. Right click and then evaluate results. Okay, so this is the results we have. Let's do one thing, just to hide the impactor and the wall. So I'll go this way, right click and hide body, and also right click and hide body. Okay, now we can see the animations of it, and just increase the time, animation time. Let's play the animations. Okay, you can see now. Okay, right. You can extract the other results as well. Let's right click on the solutions. Can you see the stresses? Retrieve this result. Okay, here is the stress. Oh, fine. In the solution information, we can get other data, right? Time increment and the energy conservation data. Okay, here we'll get the graph, also momentum summary. Okay, these things I will explain. If you want to understand this graph, then I can explain in another video, right? So I request all the viewers, those are into the finite element analysis domain, please like and subscribe my YouTube channel. And if you want me to make particular videos where you are facing problem or challenges, you can put in the comment box, and I will make videos of those problems. So thank you very much. Thank you very much all.